Hey, I'm going to try this video again. I actually thought I made a mistake, and so I stopped doing my previous video, and I realized my answer key was wrong, and that my video that I had just made and stopped making was actually correct all along, which was awesome to realize that my key has been wrong for the last couple of years. So good to know. So anyway, I'm going to just reveal what I have here, although it's mainly just done, and I'm just going to talk our way through it. So in problem 10, we know that this water is flowing out of this thing. And a very, very important thing to note is that if you have a cylinder, the radius being 12 is a constant. So the fact is that is a constant. That is your friend. You get to plug that in super duper early. So when you start with your equation of pi r squared h, we're going to just jump in there and call r 12. So we got 144 pi h. Easy little equation. Now, of course, when we take the derivative of 144 pi h, it would be 144 pi dh dt. Now, that's actually, we've pretty much done all the work now, because if we have that as our equation, and in the given information, they told me that my dv dt was 18 because water was flowing in at 18 cubic feet per minute, all I literally have to do is divide both sides by 144 pi. We're not getting a nice answer, but it's not bad. We're kind of done. That's the end of that question. You'll notice they never said, hey, when the height is this or anything else, because really it doesn't matter what height is. As long as you're pouring, the height's going to move at that rate because it goes straight on up. So there's no change. Now that's in direct contrast to problem 11. In problem 11, on the other hand, we have waters flowing into this conical tank. Now, in a conical tank, we don't have the situation where all those things are constant. We know that as it flows in, the ratio of the radius to the height is a constant. So I made right here a ratio of the radius to the height is 12 over 7, or I cross multiplied. Now, as it turns out in the problem, they keep referring to height. And so what I did is I solved this for r, so that I could come into the original problem and get rid of r in terms of h, okay? So that's kind of an important thing. Originally, when I did the problem, I solved for h and got rid of it so that I had everything in terms of r, but it's actually better since the problem is all about height. So anyway, I changed everywhere where I see an r to 12h over 7. So that's what I have right here. There's 12h over 7. Now keep in mind that's being squared, so I get 144h squared over 49. Now you'll notice that this doesn't say over 49, it's 147 because I multiplied the 3 in. Now the nice thing is at this moment I've actually set myself up for success because it's a very simple story with only the two variables, v being dependent upon h. So dv dt, remember this 144 pi over 147 is just a constant. So I multiplied the 3 down and dropped it to a 2. And the reason why this is a little bit different is because as I multiplied that 3 down, I just simplified it a little teeny bit. So that's all that was about. And hopefully I didn't make a mistake there, but hopefully we had 144 over 147. We're going to multiply that by 3. Hopefully that does it right. I'm getting a different number, 144 over 49. Shoot, that felt wrong to me. So this is 144 over 49. Let's fix that real quick. And so all we have to do then is I need to take 144, and I'm going to ignore the pi for a second, over 49. I'm going to multiply that by 25, and I'm going to take the 18 on the other side and divide it by that. And try that again, 144 over 49 times 25. We're going to take the 18 on the other side and divide, math enter. And so it would be 49 over 200 pi. So this would be 49 over 200 pi, and that would be my value, which of course now I need to fix that again. So 49 over 200 pi, which again would be this divided by pi, or 0.07 0.076 I guess is what I'm going to call that, feet per minute, and we're done. Now, of course, our last problem then comes in with a balloon. And since I just kind of wanted to be done with this thing, I'm just going to jump at it. We know the volume of a sphere is 4/3 pi r cubed. So dv dt is 4 pi r squared dr dt. And the problem, we know that the radius is given to be 6. And we are given that air is being blown in at 3 cubic feet per minute. So we know dv dt, we know r. The only thing we don't know is dr dt. We just do a quick division. Now keep in mind, you can write it this way or you can simplify it out. It doesn't matter. And then of course, since the surface area is 4 pi r squared, ds dt is 8 pi r dr dt. And again, since we know dr dt from this thing, because it says at the same time, so if dr dt is 1/48 pi, we can utilize the information we already at hand and simplify it down, and ds dt is 1 square feet per minute. And please notice that the units on this one would be foot per second, and this one would be foot per second as well. But this is area, so it would be surface area would be foot squared per second. And so that's going to kind of finish up that video on all of those pieces. Hopefully that's helpful, and I'll see you back in class. Let me know if there's any way I can help you. All right, bye-bye. Have a good day.